Well, hello friends. Today we are going to keep working on the Windows Server in Serenity, and it's going to be about purgeable memory and sort of taking the concept that we were putting in yesterday, where when you minimize a window, we now make the backing store for that window volatile. So we can see here that there's about almost 800 kilobytes of volatile memory in the terminal process, and when we bring it back up, the amount of volatile memory here goes down and becomes non-volatile. And that just means that the kernel can take that memory away at any time. So, when it is volatile, the kernel can take it. So if we were to run purge, we can see that this terminal right here will, I don't know what we should sort by, maybe PID. We will see that his volatile memory will be yanked away from him. And this is pretty neat. It means that the kernel has options that can take memory away if it should ever run out of memory. But today we're going to implement a new trick. So it's going to be about window occlusion. So if I have this terminal here, and then I put this system monitor on top of it, then I can't see that terminal. Yet, it's actually this terminal right here. Yet it still has 800 kilobytes of non-volatile memory used for the bitmap that the UI is painted into in that terminal. So today we're going to make it so that windows learn when they are completely covered by another window so that they cannot be seen. And by communicating this to the windows, they will have a chance to say, well, if you can't see me, then there's no point in me having a backing store. And I think when we do that, we can also make sure that we don't even send paint events to windows that are, say, behind another window. So do we have something like that? Like, I guess we can bring up the fire demo, right? So the fire demo uses some CPU, but what if we cover it completely? In the case where it's covered completely, we could definitely do better than having it keep rendering like this. Let's see what it's actually doing. Maybe we can get a profile, because I'm kind of curious. So let's see, proc profile. What is this program actually doing? Yeah, so it is painting. And we can definitely stop doing that if it's occluded. Will be kind of a cool feature. So yeah, let's just start doing this stuff. So the first thing we're going to need is a way for Windows Server to tell programs that they, or tell Windows that they are occluded. So we're just going to make that part of the Windows state change message that we added last time. So currently we only tell Windows when they're minimized or not minimized. We can also say occluded, and this will just be sent out to a window when either it's a minimization state changes or it's occlusion state changes. And this just means that it's completely covered by opaque, something opaque, like another window. And let's see. And then in the Windows Server connection, so this is on the client side, we get this information right here. So notify state changed. We'll just include this here, message occluded. And then in G window, we have notify state changed. We'll add occluded. Okay, so full occluded. And then basically, I think that if you're either minimized or occluded, then we can make the shared buffer volatile. But if you're not minimized, and you're not occluded, minimized or occluded, That does seem reasonable. Okay. Okay. And then we have to compute the state, minimization, occlusion. Okay, and now we got to send this out. Window state changed. It's posted here. Window state changed. So this is when the minimization state changes, but we'll just add it's occluded, and I think we'll need a separate function for the occlusion state change. So we'll say so we'll have a setter for this on the window, in the window server here. So set occluded, if that's an OOP, and then window manager, the window manager, notify occlusion state changed this. Okay, and we'll just add it as a little Boolean here. So each window will now know whether it's occluded or not. Of course, we have to compute that, but it's at least it's a start. Occluded. Okay. And notify occlusion state changed. Great. So when does this actually change? I guess we should have a function that gets called to recompute occlusion state. Recompute occlusions, something like that. We'll just put that in the window manager, and we'll do it when every window moves. What do we set the rect? Set rect. Set rect. And then we tell the frame that the rect changed. And we tell the window manager that the rect changed. So this is very nice of us that we let the window manager know, because then we can just recompute the occlusions. Okay. So window manager, recompute occlusions, and then for each visible window, I guess for each visible window from back to front. How do we do this? For each visible window from back to front. Any opaque window contains rect. So if any opaque window contains the rect, we have a way to query that. Or any opaque window above this one contains rect. Oh, that's even better. So that's what we want. We want to ask, does any opaque window above this window contain this rect? And then we can just pass in the window rect. Okay, so if any opaque window above this one, above window, contains window frame rect. contains means that it's completely contained within an opaque window above this one. So if anyone above, then we'll say window set occluded true, else window set occluded false. And then we will keep iterating. So maybe it's that simple. Let's see. Could it really be this simple? That would be amazing if so. At least Windows Server seems to compile. Now we have to compile literally everything else. Wait, can we make this go faster? Something is not right with these make files. We always rebuild a lot of the same things. That can't be right. I guess I'm gonna help him a little bit. All right, come on now. So here we are rebuilding libhtml after building browser. That can't be right. Now we're building libgui after building all the apps. Also not right. Yeah, something is a bit rotten in Denmark here. I mean, maybe if I just let it build by itself, it would finish by the time now. So, by the time already. But, why do you relink everything every time? Probably I should just sit down and look at the build system this afternoon. But I have, my nephews are visiting later today, so it's going to be Lego time, which is going to be amazing. So I guess we just built. Let's test this out. All right, so what happens if we have a file manager, and let's just sort by PID, this guy right here. Can we cover him and change his? Yes, we can. How cool is that? So purgeable volatile, look at that. When we uncover the file manager, his memory becomes non-volatile, half of it. But when we cover him, whoop, it will pop over to the other column. That's pretty neat. And of course, this means that the kernel can actually take that memory. Now we're taking it manually, but if the kernel starts running out of memory, it will also just take purgeable volatile memory from processes that have it. Now, this did not go super well here because we actually took it, but now that we uncover the program, it does not redraw until we click on it. That doesn't seem right. So maybe we have to trigger a paint if we lost our buffer. So let's see, set non-volatile, bitmap, null putter. I guess when we make it non-volatile, we should cause an set non-volatile. Then we'll cause an update also. So we'll do update And why do you have to rebuild everything? I just touched that one thing. Ah, whatever. Okay, maybe. Let's see. Can we make that happen again? Cover it. Okay, we got file manager. Got all of that purgeable, volatile. Boom, take it. And uncover, and it's still black. So why does it turn out like that? We call update. With an empty rect. Okay, so what happens if we call update with an empty rect? Does that not work? Maybe we have to help it a little bit and let's see, G window update. What the heck is a rect of a G window anyway? Rect. Okay, so cover it, purge, and uncover, and now it is repainted. All right, so it's that simple. We just had to make sure that we update the whole thing. Seems like sending an empty rect to update was not doing the trick. Maybe we should have a variant of G-window that does this. I don't know, it'll just be like update 0, 0 with height. Because that's what I expected update to do. So let's just do it that way. Okay, that's pretty cool. Now, something that's not going to work here, I think if we cover this guy and we purge, yeah, the window switcher. So if you bring up the window switcher after a purge, you can see that it's black. So boom. And that's not very good. So now it doesn't go away. I guess we have to re-occlude it. No? Why doesn't it go away now? Okay, so this is a little tricky. We gotta, when we bring up the window switcher, then we need to tell everyone that they are, nobody's occluded anymore when the window switcher is up. So how do we do that? That's called switcher. So I guess recompute occlusions should take that into account. So if M switcher is visible, set occluded false, because then nobody is occluded. Otherwise, it's based on other stuff. So WS window switcher, I guess when we should notify, in set visible, we should notify the window manager. Can we maybe even recompute occlusions? Yeah, that might be the easiest. And then another thing is, I think when we change the opacity of a window, then we need to also take this into account, because if something is occluded by a semi-transparent window, then it will be the recompute occlusions will figure out that, okay, this is not opaque, so this is not occluding me, but if the opacity changes, we're not going to recompute right now. So I think that means that we would be able to, because there's this keybind that if you press down the window key and use the scroll wheel, then you can change the opacity of the window under the cursor. So if you do that, I'm pretty sure that we are going to reveal a purged backing store underneath. But let's see, set opacity, where do we even set that? Set opacity. Yeah, it's just like this right now. So set opacity, this is the mouse wheel with the logo button pressed down. Maybe we should rename that to super or window. I kind of like thinking of it as the window key lately, because I'm using it for window management. So like the window key is used for window management. It just makes perfect sense. I finally found a way to rationalize why I have a window key on my keyboard after 20 years or however long. So I think, let's just verify that we have that bug, but I think basically we're going to make set opacity trigger a occlusion recomputation. Because there are other calls to set opacity as well. Like the window client can decide to change the opacity of a window as well. So let's take one of these guys and cover it up. Okay, so we should have a bunch of volatile memory here, 2 megs. And then we'll trigger a purge. And the file manager has now no volatile. And then let's change the opacity of this system monitor. Yep, indeed. It comes through without change. Now if we move the window, it triggers a occlusion recomp. So then everything turns out okay, but we're gonna have to, let's just put this out of line. So we'll do void WS window set. Let's set opacity. If it's exactly that, then return. Well, comparing is unsafe. Yeah, but I only care if it's exactly the same. Modify opacity changed. This opacity. we can send... Oh, we don't need to send anything, actually. Hold on. We just need to recompute occlusions. That's what I want to do. And we can just rebuild Windows Server. Wait, I already did this. Alright, come on now. Come on, File Manager. Come on, System Monitor. Okay. And let's do a purge. Purge. Okay. Now let's slowly reveal what's underneath. File Manager. That's pretty cool. Okay, and I wonder if we did that switcher thing right. So now it has no backing store. If we bring up the switcher, yeah, it had a backing store. So the moment you bring the switcher out, we consider everything that's not minimized, or actually we consider everything not occluded, but minimized windows actually don't appear in the window switcher. Maybe they should, but this guy now gets his bitmap back. So that's pretty neat. I love that these things are live, by the way. It's so cool. It means that you can do this, and you can see the fire here in the switcher. Very neat little effect. So what else was I talking about? So now fire, by the way, is occluded, but we're still painting it. Oh yeah, I wanted to maybe not do that. So what happens if we purge the fire? It's volatile. I guess it's still painting. So we can do better, but let's do one thing at a time here. So let's commit the stuff that we have so far. Windows Server plus libgui. Mark backing stores volatile backing included Windows Server. Now computes tracks whether windows are occluded, covered, completely covered, meaning that there is something opaque, meaning that they are covered, completely covered. One or more opaque windows sitting above. Yeah. This is state is communicated to the Windows via Windows state changed messages, which are then allow GWindow to mark its front. It's actually the front bitmap in this case, or mark window bitmaps volatile occludedness. Mark its backing store volatile. This is another nice. This is pretty cool and helps. And this reduces the effective memory impact of windows that are not at all visible to the user. Very cool. Very cool. Okay, So let's try to get rid of the paint events while we're occluded. So I guess we already have something for minimized. We don't send paint events to minimized windows. And I'm guessing it's right here. So when we try to post a paint message to a window, we look at, is this window minimized? If so, don't even bother. I think we can say if window is minimized or window is occluded, then we can just not send the paint message. Let's see how that works out with the Fire program. Fire, so it's pretty active. Right here, sort by PID. What if we cover it? It goes down to 4%, uncover it up to 8%. So still doing something. What are you doing? What happens if we purge right now? Yeah, then he loses his backing store. But if we bring him back, it's black. Oh shit, okay, so... Wait, why was it like that? That's interesting. So what if... Let's try that with the file manager. Oh, something here is not working right. Start over. Let's see, so if we minimize, purge, bring back. All right. Why was that not working for the Fire program then? Minimize them, we purge them, bring them back. Oh, maybe if, let's see. Yeah, okay, so what the heck is that? I guess it's that it doesn't become minimized or unminimized, it just moves to top, because it's already unminimized. So we have to recompute occlusions when when changing the window stack order. That's good. So we had this change right here. I think this one is good. So if the window is occluded, there's no point in running the paint events. So we'll say window server, don't send paint events to occluded windows. We wouldn't be able to see what they paint anyway, and nobody should be using paint events to drive program logic. So I think that's a super good optimization. It just means that if something is covered by other windows, we'll never tell it to paint because you can't see what it's painting. Of course, it's only when it's completely covered. So there's not a single pixel of that window visible. So painting it is completely pointless. And then, right, so when we change the window stack order, so that would be window manager. We have like move to front. Move to front and make active. We should probably do this in all of these guys here. So add window, we should recompute occlusions. So we'll do that. recompute occlusions. When we add a new window, we'll do it when we remove a window. And we will do it when we move a window to the front. So these are really just like the window stack somehow changed the order of things. Whether it was adding or removing a window or just taking one window and moving it from the back to the front. That should allow us to create a new backing store after purging something that was occluded but not minimized. So let's see, let's purge. See that Fire lost his purgeable backing store there. And yeah, it's still purged. And then if we bring it up, boom, it pops into place. And you never know that it didn't have a backing store to begin with. It's pretty neat. So I really like this, and I really like that the CPU goes down when something is covered, as opposed to when it's not covered. So you can see here that even if we just have like a tiny little sliver of the window visible, CPU usage is definitely higher than if we were to cover the whole thing. You can even hear my computer's fan calm down a little bit when you cover the window. That's super duper cool. Yeah, you can see the program here. I guess it actually prints something out when it paints. That's in the timer event. But we increment the number of cycles when we paint. Yeah. So, very, very cool. Very cool. Let's see. Windows server. Recompute. Window occlusion. When the windows on a window stack changes. Adding or removing windows, or moving a window from the front to the back. We have to recompute everyone's occlusion states. Okay, so I think this is probably going to be it for today's video. So if you made it this far, then thank you for watching and for hanging out. While we continue to explore what kind of interesting things can be done with purgeable memory. I think this is super interesting subject, and it's really really cool to have the system like mature more and more so that we can start to do more and more sophisticated things like this. I'm really, really happy with this optimization because now I know that that if I'm doing something in a maximized window, I don't have to pay for the backing stores of all the windows that I don't see, which is really cool. Because the kernel, even if they're still allocated, the kernel can come, if he runs low on memory, he can just come and take that memory. So really cool, and really interesting exploration, I think. So I hope you find it somewhat interesting as well. And I gotta say, I wish more systems would have this particular behavior, because I think it's a really simple but extremely powerful and useful optimization technique, which we will continue to play around with and see what else we can do. All right. So that's enough of me saying how much I love purgeable memory for today. So thank you again for hanging out and for commenting, liking, sharing the videos, subscribing, everything else. Really appreciate it, and I hope that I will see you next time. Bye.